All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have, let's determine the moment of inertia about the centroidal x prime axis. And we're told to assume r is 12 millimeters. So if we're looking for moment of inertia about the centroidal x-axis, the first thing we're going to need to do is figure out where is that axis located at. So we're going to have to do centroid, and then we can come in, add into that. Let's find moment of inertia afterwards. So if I were doing this, the first thing I would do is just guess where do I think that centroidal axis is located at. This is 80 millimeters tall. If we took that circle out, it'd be right in the middle. So I would guess that it's loosely right in the middle of everything. So I'm going to come in and put in my centroid here. And it should, as we cut out a hole in the bottom, it should shift the centroid upwards just a little bit. My exact location doesn't really matter in here. I'm just trying to get this so I can sketch in what's the centroid dimension I'm looking for. I need to get what's my distance to that axis I just labeled here, my x prime axis. An x-axis passing through what I'm guessing is the center of the shape. My distance I'm looking for, though, measures from the x-axis up to that. Well, that's a y distance. So I should be looking for y bar as I come in and tackle this problem. So I can get that labeled in here. Y bar is what I'm looking for. That means as I come in and set this up, I need y distances for everything. Only y tilde a to find centroid, y bar. But I'm going to end up making a table. For my table, I need to split this up into regions that I can work with. So I would come in and say, well, I have a big rectangle in here. Let's call that shape 1. And once I have that one done, I'm going to need to get in my second shape, a circular hole in here. Shape number 2 for this. 2 is the hole down there. 2 pieces in there. That means I'll have 2 rows in my centroid table. I should be able to tackle both of those, though. So let's come in and make our table, find centroid. So my table I'm going to set up. I will make a column for what's my area, the name for it, or what's the piece number in there. What's the actual area? That'll be we're in millimeters for everything, so a millimeter squared, squared. Then I'll need what's my y distance to the centroid of each piece in here. That's my y tilde value. It's a distance, so it'll be in millimeters. And then finally, I'll multiply these 2 columns together to get me a y tilde a. That'd be in millimeters squared times millimeters. That'd get me cubic millimeters. Millimeters cubed. Once I have that, I can then come in and find my centroid. My general formula for y bar here should be that it's the sum of my y tilde a column divided by the sum of my area column. So I'll put in, I need to sum those 2 pieces up then. Just come in and start filling this in. We know we need a row for each piece. So I need a row for shape 1, my rectangle. I need a row for shape 2, my circular hole. And I need to come in and at least a couple times, I need to sum things up. So let's put a summation row in here as well. Then we'll start filling this in. For shape 1, what's my area of this? Well, my base is 40 millimeters. My height is 60 plus 20, or base times height, 40 times the height, 80. 40 times 80 is 3,200. And that'd be the first piece there. The second one is, what's the area of that circular hole? Right now, shape 1 covers up that hole. I need to actually subtract it out to get the right piece or the right area in here. So I'll come in and say that's a negative area because it's actually missing. And it's pi r squared. The radius of this hole we were told to assume is 12 millimeters. So pi times 12 squared. Or this is negative 452.39. I do have a sum of my area here, so let's go ahead and sum that up. I should get 2,746.61. Then we can move in and start getting my y tilde values. What's my distance from the x-axis, where I'm measuring y bar from, to the centroid of each individual piece in here? So shape 1 is a rectangle. To get to the centroid of it, I would just need to go to the very middle of it. If the entire thing is 80 tall, I need to get to the middle. So 80 divided by 2 is 40. For the circle, we need to just measure to the very center of it, and we're given that dimension. It's just 20. So we can fill that one in as well. I don't have in here a sum of my y tilde, so I'm going to cross that out. I don't need to sum that up. And that's just multiplying these two columns together. 3,200 times 40 is 128,000 even. 128,000. Negative 452.39 times 20 is going to get us negative 9,047.79. And that column should add up 128 minus, because we're adding a negative in here, 9,047.79 is 118, 952.21. Which gives me everything I need to find my centroid location then. That centroid, my y bar value, I can come in and say, well, y bar, we wrote the equation down a minute ago, we're just using it now. But our y bar should be the sum of my y tilde a, 118, point right here, 118, 952.21, divided by my total area, 2746.61. Or my y bar ends up being 43.29 millimeters. I gotta know that to figure out where is that axis located at, so I can then do moment of inertia about my centroidal x-axis. So that's kind of the first half of the problem, building up into moment of inertia. From here we can come in and say, let's try to do moment of inertia. So if I have two pieces in here, I really am just adding those together. My total moment of inertia, Ix prime, about that centroidal axis, will be, well, the first one's positive, so I'll just say Ix1 prime. And the second one, I'm just going to treat it like it's positive until I find the moment of inertia just for shape 2. But I know I'm just going to subtract it out. So minus Ix2 prime. And that's all I have to tackle in here. So let's get Ix1 prime sorted out. Ix1 prime should be, we should have formulas that we can take a look at. They're normally in the back of your book or else handed out by your professor. We can take a look at those. Ix1 prime, it's a rectangle. So we can say this is the moment of inertia about the centroidal axis of just that shape. Let's actually write down the parallel axis theorem. We're going to use this as well. My I equals I bar plus d squared a. Let's talk through this a little bit, and then we'll come back and start filling this in. This is telling us our moment of inertia about any axis I want to take a look at in here. For us, that's going to be this x prime axis. That's equal to the moment of inertia about the centroid of a shape. So that'd be the centroid of shape 1, the centroid of shape 2, plus the distance in between these two axes squared. What's my distance from the centroid of shape 1 to the centroid of the entire object? Well, that's easy because we fill this in. That should be 3.29 millimeters. The difference from the bottom to the centroid of everything and the bottom to the centroid of shape 1 is just the difference in y tilde and y bar. We really have those pieces. I have my area already calculated out. I'm just pulling these into moment of inertia now. So my moment of inertia about the x prime axis from shape 1 is really what we're doing here. That's that I term is equal to I bar, so we need to get our Ix bar number, or Ix prime just for a rectangle, is our base times our height cubed over 12. Our base here is 40, so 40 times our height is 80, times 80 cubed, divided by 12. Plus d squared, my distance from between my centroidal axis for the entire object and my centroid of just one piece in here. So plus d squared. And if we're doing moment of inertia about the centroid, if I've measured everything in here, I can always just do y bar minus y tilde. 43.29 minus y tilde. 40. Again, that's just y bar minus y tilde for shape 1. That will always get us that d distance if we are doing moment of inertia about a centroidal axis. And then we need to multiply by the area, but I have that one already, 3,200. If I calculate that out, I'm going to get here that this is 741, 366.25 millimeters to the fourth. And don't get too hung up on what a millimeter to the fourth means. It becomes a really useful engineering property for us. We just have to be able to work with that. That's one piece in here. We have Ix1 prime. Let's find Ix2 prime. So my Ix2 prime. As we're doing this, we're going to pretend everything is positive because we subtract the entire thing out in this. This is, if we look at moment of inertia about the centroid of a circle, it's pi r to the fourth over 4. So my Ix2 prime. Now again, the parallel axis theorem, that's this I term equals I bar, pi times the radius, 12 to the fourth over 4. That takes care of our I bar. Again, we can look those formulas up. Plus our d squared, my distance from the centroid of the entire shape to the centroid of shape 2. Plus, that's again just y bar, 43.29 minus y tilde, 20. And I forgot to square this up above, d squared times the area. Again, we're treating this like it's positive because it makes the math work out easier. This is 452.39. Really, we need to subtract both halves of this. If we try to put the area in as negative, people tend to forget to also make this half of it negative. Treat it like a positive and it's easier. Our two numbers here are, kind of like we did above, that's really just our y bar minus y tilde, this time for shape 2. And it's going to get us, what's that distance between my two parallel axes in here. But calculating that one out, I'm going to get that this is 735.39. My final steps then, I really have all the work done. I just need to combine it together. My Ix prime should be Ix1 prime, 1,741,366.25 minus Ix2 prime, 261,735.39. And computing that out, I'm going to get my Ix prime for the entire object. Also, I subtracted this because it's really a whole. We know we're subtracting even though we got positive here. But I'm going to get 1,479,630.86 millimeters to the fourth. And that's going to be our final answer for our problem. Again, if we're tackling moment of inertia about a centroidal axis, there's a very good chance we're going to have to find where is that axis even located at. And that's going to be our first step as we come in and tackle problems like this. But we can do these. Hopefully this is a helpful problem for you. If it was, hit those like and subscribe buttons. Stick around. Let's get you an A with JJ.